we're going to do 3D modeling sort of basics this week. And let's see, I will share my screen before I start talking too much. Screen share, and was looking for this. All right. And then a couple other, hold on, I'm adjusting some settings. Nope, not that one, close. Display settings and taskbar. Automatically hide. I should have done this ahead of time. Okay. All right. So we are going to pop into here, and this week is all about modeling in 3D. We're going to cover sort of like the basic terminology that you might need, because, you know, there's a whole collection of us, and we're headed into this unit where we're going to be focused on 3D modeling and 3D making. So a lot of 3D design, and then 3D printing, 3D scanning, and then some other ways to make from a 3D design process, which we're going to go deeper and deeper and deeper on. The obvious connection will be between 3D design and 3D print, and that's sort of where we'll stay this week. But definitely, I feel as though this is going to be an area where your experience is going to guide where our discussion goes during this class, because some of you might already totally be pros at this thing and have other questions that you want to ask. Some of you might have no idea with some of these pieces, or they might be totally new to you, some aspects, and so we should then cover them in depth. But either way, we're going to go over sort of the basics of 3D modeling in this place, and then make some solid recommendations for how you can get started, because it's a skill that does take a little time to build up. However, I really love 3D modeling because of what it does for the process of making ideas real, right? I've been, since week 1 or week 2, I talked about how the more realistically you hold an idea in your mind, the more you can evaluate it and redesign it and fix things. And so 3D modeling is really going to be a way for us to hold ideas in our mind. The example I gave way back when was Mario at different levels of resolution, right? The more resolution you have in your Mario character, the better picture you get of what he looks like. And so we're sort of going through that as you take an idea from a napkin sketch to a more detailed drawing to a 3D model. And so we're going to go through this progression. So this week, we're going to really focus on some 3D modeling software options. There's a very large net that can collect. It's not like the handful for vector design. Then we're going to go through some really common 3D modeling concepts, the sort of bread and butter items, the things that absolutely should be in your tool set no matter what software you're using. Then we'll talk about some more advanced 3D modeling concepts that still, I would say, are kind of common across most softwares. Then we're going to look at alternative 3D modeling strategies that are really cool. Some of them are really new or really just out of this, like totally different. And then we'll go over some of the basics of 3D printing. So we're going to cover lots of ground this week, but if you have any thoughts or any questions at any time, please feel free to chime in so that we can talk about the things as they come up. But first up, let's talk about all the software options, because there are a ton of them for 3D modeling, and it's a hard landscape to make sense of. This is the crazy slide of all the different programs I could think of that have you 3D modeling. And so some of them are really big, like corporate entities. A couple of them are made by a single person. And so there's all sorts of different levels of engagement here. And so I would be curious to see if anybody has tried any of these different 3D modeling softwares. The one that we're going to end up recommending is Fusion 360. But there's tons of good ones. Is anybody, all right, anybody ready to unmute and tell me if you've got any experience with any of these?
Yeah, believe it or not, Unity and Unreal Engine.
Cool.
In a past life, I worked in an organization that was interested in demoing video games for certain applications in their business. And it was pretty cool. Complicated. At the time, YouTube wasn't really like the source of knowledge it is now, but was pretty awesome.
Yeah, that's cool. Those are two that I know have tons of potential, especially in the video game space. But I have not delved into them because I feel like it's such a quagmire to hop into. I've installed them and like opened them, but that's the depth of it. Um,
Um,
what, yeah, Ada.
so I do a lot of 3D modeling with Shaper 3D. It's called SHAPR 3D, which is only on iPad OS. So like it has a limited ecosystem. But I mean, I use it all the time for work and for other things. And like I've during these classes, I've like put up a whole bunch of 3D models at points showing like the nightstand idea I was working on or things like that. And those have all been in there. And since it's it's iPad software, it's really nice because you can use it with a pencil and stuff, and it's like it's almost like drawing in a lot of ways. But you end up with precise 3D models. And then I've done some Fusion 360, not nearly as much. And I've like downloaded and dabbled in Rhino, and I've dabbled in FreeCAD, which is not very intuitive to me. I like Fusion 360 much more.
Yeah.
I've been meaning to learn Blender, but I haven't.
Cool. Yeah, it sounds like you've got some experience. There's tons of different options. And they're really all over the road.
To anyone with an iPad, I highly recommend Shaper 3D. There's like, it's got pretty good support. There's a lot of like video tutorials on it. I think it's like fairly intuitive to get going on it. And there's also like a free tier.
Yeah, free tier is great. That
There's,
essentially,
I think there's also an education tier, which then is free, and it's like the full version, which is what I have. But so if you know anyone with any sort of .edu email address, or
yeah,
which is what I did. So
yep. Yeah, having with a lot of these, having a .edu email address is really helpful for sure. The
or just for someone who's willing to,
yeah, we should say
emails.
For the sake of clarity, don't try and fake it. If you're really in
Oh
educational
no, I would never.
Of course you wouldn't, Ada.
I would never recommend that people do that. I would, yeah.
Of course, yes. So, and Kate reminds us that we're recording. So the clear thing here is that we're specifically for the class not going to make any sort of requirement that you use one of these, but pretty much all of the tutorials are going to come in Fusion 360 because it does have a free hobbyist tier that is free unless you're actively making a certain dollar amount of money off of it. And they have for a long time been very friendly to makers with that free hobby tier. They have just this past, it was the end of 2020, they did tighten it up a little bit because there were some small companies that were taking, or maybe even medium-sized companies that were taking advantage of that hobbyist tier, but they're totally, it's totally accessible and you can have up to 10 designs. We're gonna look at that a little bit more. But definitely there's more examples. Kate's saying that Colin at MakeHaven works with Blender if you're looking for facilitator experience with that one. There's tons of these that are really good. And I downloaded Blender back in 2004, probably somewhere in like that. Haven't been playing with it since then, not as actively as I do now with Fusion 360. But all of these are options that sort of have, I would say each one has its own like character and personality and things that are a little bit different about it. Like ZBrush is on the Oculus and Onshape is in the browser. OpenSCAD is entirely text-based. Antimony is made by one individual person and it's volumetric, which is really crazy. Rhino and Grasshopper are a really good pair that go together for doing sort of programmatic design. SketchUp is really well loved by architects. like we said, Unreal and Unity are mostly for games. Medium is another one that's in VR. Maya, Inventor, Revit, Autodesk, and Fusion are all Autodesk products. Tinkercad is an Autodesk product. And so all of those fit into one umbrella. And if you have an education account with them, like I'm a teacher, so I have an education account with them, it's a really great thing. The hobbyist tier is also delightful. Solidworks down in the bottom left is probably the gold standard for industry design. If you're doing engineering, most companies are going to want you to have experience with Solidworks coming in. And so it's definitely a good one to know. There's no free tier. They do have fairly friendly educational things, but you need to register with them as an educational entity, I believe. So it's a little bit
I am
wonky.
sticking with JR on SolidWorks. We did have a discount code there at one time. I think it might have expired, but I will let you guys know if I find out if we have another one. They did offer us a really good deal at one point. So
yeah. And so there's tons of interesting things. They've often been very friendly to anybody who's a registered Fab Lab. They have a good relationship back and forth with those. And so there's all sorts of interesting things to look at across this spectrum of softwares. But each one, I would say, has its own character, right? And so you're going to have different relationships with different ones of these. Like I would agree. I think that FreeCAD has really come into existence recently, relatively recently, and it's going to get better as time passes. I'm like cheering for FreeCAD to be wonderful, but as of right now, it just doesn't quite click in my head how it works. So, we just keep moving forward. Now, the good news is if you can find these slides on the Foundations page, every one of these logos is a link directly to the software. So you can click your way into what these are to see a little bit more about them if you'd like.
I mean, the nice thing about FreeCAD and Blender, although like I said and you said, I think FreeCAD's a little bit tricky, is they're open source. So.
Yes, which is absolutely great. I really am all about an open source one.
And so is OpenSCAD, but that's like yeah, it's just
OpenSCAD is its own game. It's entirely text-based 3D modeling. We're not going to go into it today, but it's totally cool if you want to explore. I would say that if you were trying to make sense of that ecosystem of software options, I would put them into 3 different camps or 3 types. You have the sketch and extrude type, which is the one that I feel the most comfortable with. That's good for engineering design. It's a pretty accessible system. And we're going to explore the sketch and extrude model a little bit as we go on with the next few slides. But that is one camp. Then I'd say there's the 3D mesh designer. Those are for people who are like digital artists, where they really sort of want to mold digital clay to make their shapes. And so there's even special interface tools for people who are really molding and squishing 3D digital clay. That's totally a thing that can happen. And Blender is really good at that, but lots of the different softwares are pretty good at that. And then there's volumetric, which is a neat, interesting camp where 3D-ness is a first principle in the software, where you're adding in spheres and cylinders and cubes, and those shapes are added and subtracted from each other. So there's some really interesting things that can happen in there. I feel like that one is definitely a little bit harder to wrap your head around as a beginner, though. So we're gonna pass on that. We'll be focused on the sketch and extrude space, which is definitely a mechanism that takes a little bit of exploring. And you might think about toothpaste a lot. The sort of extruded cylinder you get out of a toothpaste tube is very much where we're going with this. So we're going to recommend one, which is Fusion 360. It's the recommended choice. It is not a required choice to do Fusion 360. Like, for example, if you were running on a Chromebook, Onshape, I've actually really enjoy Onshape. I think it's great. It was made by someone who was on the SolidWorks team, and then they made a browser-based system. And so it looks like a lot has changed over the past year. Their logo changed. So there's a couple things that might be in flux with Onshape. But last I checked, it was totally free as long as you were willing to have your designs be open. But Fusion 360 is fully featured. Their hobbyist license is great. It lets you have 10 designs that are active at a time, and you can turn them inactive or reactivate them without any real hiccup. You just need to log in and make some changes. But it does give you quite a bit for exploring. And then they want to make it a very low barrier so that if you come up with a great idea and you want to start paying for it because now you're a company who's selling things that you design in Fusion 360, they want that to be as easy as you just check the box and it happens. So it's totally a great system. It'll be, and they really have been friendly to makers for a long time. So since the start of Fusion 360, which hasn't been that many years, maybe 2 or 3 years total. And so it's a relatively new one, but Autodesk is a well-established company. So it's definitely the thing that's going to replace Autodesk Inventor, which is there has been a key player in their design space for a long time. And the writing is on the wall that Inventor is going to go away and Fusion 360 is going to become the new normal. But if you're professionally designing things, you're probably doing that in SolidWorks, because it's just sort of the industry standard among engineering firms. There's lots of other interesting ones that are out there, but this is the one that we're gonna stick to. And all the tutorials that you're about to see, all the different images were built in. So let's go over the 4 most common things that you would do with a 3D design software, just to start to wrap our heads around, like what is this and how do you draw anything in 3D? Because it's a lot different than drawing on paper, but it can start with pretty much the same things. So we're going to do sketch, extrude, revolve, and Boolean coming up first. So the first thing, anytime you're coming up with a design, and a 3D design is no different. You saw on the chat that I recommended making a doghouse, just a representative doghouse, not that it would really be one that you make, but just to get the idea across of the software and like, how does it work? It's a nice hello world kind of introduction to a software. A sketch works just like a sketch would be on paper. You specify rectangles, arcs, lines, some of those things. One of the neat part about a 3D design software is that sketches can have constraints and relationships and dimensions, which you can see in the sketch that I've got here. But there's lots of different interesting things that you can do and see with a sketch. But they set up the shape of what you're going to turn into something 3D. There's a lot of interestingness to sketches. And you can really go crazy with understanding how complex you want them to be. A lot of people, when they're very new starting in CAD modeling, they'll just draw one sketch, do an extrusion, then draw another sketch and do an extrusion. And you go like that over time, where it's sort of one sketch equals one extrusion. As I've gotten better at Fusion 360, my attitude has been to draw sketches that really represent what I want something to be, and then from there do multiple extrusions. And we're going to see what that looks like in a minute. But drawing up a picture, very much like you would on paper, is something that you're doing here with a sketch. It has to happen on a 2D plane, and we'll see what that looks like in just a second. I can also I have Fusion 360 pulled up right here, so I can drag around. I can hop in and show you what this looks like if we're modeling things and really going in. I've got the representative doghouse right here. So this is the doghouse that we're talking about. And I'm able to rotate it around and look at it in 3D and sort of hop in to see what's going on here. So in this space, I can show you what the sketches look like if I just open this up. So that's that one sketch. And in this particular model, I just did one sketch and a few extrusions and operations from that. So you don't have to draw this way. You can draw a number of ways, but a sketch just gives you something to extrude from. And so sketches like this are really helpful. From there, the next step, once you have a sketch in a 3D design software that's a sketch and extrude sort of model, then you extrude. And so up at the top, I've got 2 GIFs of what extruding really is and what it can be. Extruding is where you take a part or a whole sketch and you sort of extrude it into existence. This is where the toothpaste metaphor comes in. You got the circle that is the end of the toothpaste tube, and then you squeeze it and out comes a cylinder. So in this case, I have an irregular pentagon, I guess. It's a 5-sided shape. And then we just drag this along and out extrudes a 3-dimensional volume from that. And so that's the one on the left. And then the one on the right, I did another extrude feature, but you can do it subtractively instead of additively. So I'm able to sort of subtract out the door from the shape. And so you can extrude in positive or in negative. Those are both totally reasonable ways to do your extrusions. And there's lots of other parameters. If you're extruding, you'll get this in Fusion 360, you'll get this extrusion menu where you can decide how far you want it to be. That can be based on dimensions that you have set up. You can say if you want to extrude to one side or multiple sides. You can decide if you want to be symmetric. You can have it start right at the profile of the sketch. You can also, and this is something that it took me a little while to understand, but you can start it offset from the sketch, where the sketch sets where it's going to be. But you can actually do the extrusion offset from the sketch in another plane, which is kind of cool. There's tons of things. Let's see. We've got pulling up a link. Oh, yeah, that's a really good example of something extruding. This little extruder example is perfect for just showing how you could totally move this along and get whatever weird shape you wanted coming squishing out of there. These little like hair guys, that's totally a thing. There's tons of good examples of what this could look like, but extruding is exactly the idea that we want to go with, to have that really go. Another thing that's helpful is to think about how far you want to extrude. So are you going to go a distance? You can also choose to extrude to another part of your model. And there's a ton of options that really you can go a lot deeper with here. Another one that's good is this taper angle. You can adjust this little slider right here. If you don't want it to just go straight out, you can also have it go and sort of get wider as you go or come inwards. There's lots of different options for how you can make this happen. But the sketch and then extrude dynamic is totally a part of what we're doing for a lot of these examples, a lot of these designs. The next way that I think is worth putting in as a main way to build something is with the Revolve tool. And so in addition to extrude and sketch, the Revolve tool will let you build things where they're rotated around an axis. And for this, it's a little bit different, right? You're coming into 3 dimensions. There's some curve that happens naturally with it, but you're specifying a shape. And so I was trying to go for like a weird donut-y shape here. You have a shape, and then you need to have an axis of rotation that you're going to spin around. And I'm spinning around just the y-axis of this entire part. But you can spin it around for a whole rotation. You can do parts of rotations. There's tons of different options that you do with this, but this is a really important way to think about how do you want to make something that's curved, right? It may be, this one I use a lot less, but it's very useful when you're in the right context where you need to have something revolved in just the right way. And so there's a lot of examples for this. And there's even a set of tutorials that sort of wander you through these different tools that fall into the Create tab on Fusion 360, where you can create extrusions, revolutions, you can use sweep, loft, rib. There's a bunch of other ones that you can do. And I think that it's neat to explore all of these. Sweep is a cool one where you can draw a shape and then you can draw a second shape in another dimension and then follow out strange paths. We're going to see a sweep in a little bit. But there's lots of different ways that you can make things. But I would say that if we're thinking about the core of it, the main most common things, sketch, extrude, and then revolve a little bit less often are going to be the most common ones. Another one that I've really started to enjoy is combine. And this is a little bit trickier as we're thinking about how to make things. The combine tool is one that this is usually one of the tools that will decide if I like a software or not, is how good is their combine or Boolean tool. And Fusion 360 and Onshape both have a really good one. I think I might even like the one in Onshape a little bit better, just because that it's presented as a Boolean operation from the start. But in this case, if you wanted to make complex geometry, like maybe a set of finger joints, you can have the software do that for you, where you start off with a piece like the red one and then the blue one. And let's see, cut sheets and shopping list. I believe it does, especially when you get to the metal parts. There's lots of features like that you can explore. We're going to see how you get exported features out from those. It's coming. We're going to get there. But you can pull a lot of information out of these 3D design softwares. And so if you wanted to have finger joints made, you can have this red piece, and it sort of overlaps in this first design where you can see it sort of wigs out on the color, where those surfaces are in the same place at the same time. And you can have a combine tool where it does a Boolean cut and the red cuts away from the blue. so that the blue piece has teeth cut into it by the red one. You can even do a little intersection inspection in Fusion 360 to see if you have any conflicts in your materials, which is broadly useful to see if you've got anything sort of mixed up in your design. But it's also a really good way to see what's going to happen from the Boolean operations. There's a ton of different things, but I would put this into the main class of operations. This is definitely one of the things that gets a little underrated in the interfaces of these softwares, but being able to do this to build interlocking parts for a maker is super helpful, because you can define how you want your finger joints to be put together, or how you'd like to have pieces that you're going to laser cut later or CNC later, how you'd like those to be defined relative to each other so that you get nice, perfect fits. And you only have to model it half of the time, right? You only model the teeth on the red, but then it comes into existence for you on the blue so that you can use it really nicely.
Aaron had a question.
Oh, and then was that a question? Are we good?
Yeah, there was a question from Aaron in the chat.
Oh, for cut lists, right? So the question from Aaron is about cut lists and shopping lists. I know that it does have cut lists for some features. It's not one that I use very often, so I would need to dig a little bit to see where that is. Most of the time, I'll use DXFs to pull out this, like the two-dimensional shape, and we're going to see what a DXF pull is in a little bit. And actually, I'll just go
I would
into
say,
here.
like, outside of this class, if anyone wanted to like shower me with your tips about like, I'm the guy who's like, I think I know what I need to buy. I'm pretty good at like doing my homework. I can go out and get it, but like, I know I'm missing something. So if you have like little tips and tricks, I'd love to hear that.
I would need to, I know it's possible. A buddy of mine was designing a skate park with some students, and he did it all out of like 1-inch square aluminum tubes, like we have in Cut at MakeHaven. And he used, it was an Autodesk product to design them. And because it was a known metal part, he was able to say, I want to have this long of a piece, and it would just spill out cut lists. I don't know exactly what that mechanism is, but I know that it is a feature that exists probably within the sheet metal or within some of the metal tools.
Cool.
It's a whole category. Sheet metal is its own subcategory that we're going to get into next week, which is really cool. There's tons of interesting ways to make that happen. One of the things about, so like for the sake of cut lists, like as we're going down this road, if I right click on this and hit save as DXF, I can choose to save a sketch like this one as a DXF file. And this is a vector type file. And so we're just going to call this Doghouse and put it on the desktop. Hit save, and then we can open it in Corel, because I'm a Corel native. We're just going to open it there. But then that Doghouse file we can open up, and it should just import. So DXFs are really helpful because you can pull them into existence. And let's see if I find it without having lost it. Doghouse.dxf. There's all of these different options for how you can import. And so I'm going to import it 1-to-1, which is going to be big for this sheet. Let's see, 12 by 12. What if we do 1-to-2? And so new size is going to be half the real size. So we'll just plop this in, and then there's that design totally just plopped in. And I could take this directly to the laser cutter. I wouldn't want to laser cut it as is, right? I wouldn't have exactly what I want, but being able to go from a 3-dimensional shape and specifically a sketch on a 3-dimensional shape, I can then pull this and do that. Now, this is from the sketch that had all those lines. We're going to go into how you would be able to pull this without that sketch being there. Like I can just create a sketch on the surface. And when you do that, it collects all of the geometry that's there. This is sketch 2. And usually I'll do things like label it DXF and face, I'll give it some sort of a representative name. And then this DXF wouldn't have any of those pieces, that all of those lines crossing it, but it would be totally something I could just throw onto the laser and then cut. So those are all different parts that we'll look at.
You cut out for me for 1 minute. Did that happen to anyone else?
Oh,
okay.
Sorry.
No, I mean, it could be my connection.
Yeah. All right. So let's take a look at some of the more advanced ideas. These are things that, again, are still targeted towards while you're getting started, and stuff that I don't want you to miss as you're getting going. And that's essentially the theme of this week, is just trying to make sure that we cover the things that absolutely could get skipped over if you just hop in, but I want you to pay attention if these are here or not. The first one are sketch constraints. So sketch constraints seem like they might be, they're interesting ways that you can have relationships. Like you can define things as being tangent to each other, or being equal or parallel or perpendicular. And so there's lots of interesting applications for this, where we can go in, and if I'm drawing something, we'll draw something on here. I can start to draw in lines, put them all together in weird ways. And in this case, I can say, well, I want you to be parallel. Like I could define this line and this line to be parallel, and then they pop into existence that way. And those two to be parallel. And then maybe I want this to be at a right angle to that. And then perhaps I want to put in a circle like this and set it to be tangent, right? You can define geometry in different interesting ways so that you've got control over how these things are linked together, so that when you move them around, you get relationships that are what you want them to be. And so like, as I drag around the circle, you can see it changes the angle of that line. I may not want that. So you can not only specify relationships like that, but you can also specify dimensions. And so the dimension tool is another one that's really helpful, where I can say that this and this should be, let's do 180 minus 15. So you can set up relationships like this, where now if I drag this around, you can see it's definitely changing how those two play. Or it's wigging me out, this isn't flat. We can say that this line should be horizontal, right? And so you can make all sorts of adaptations to designs so that the geometry is related in ways that make sense for you or make sense to your design. There's tons of options that are available, and understanding geometry and constraints is a really helpful thing as you try and get deeper and deeper and deeper with your designs. So playing around with the constraints, geometry, and dimensions is one of the things that, as you're getting started, like when you start with designs, you may not initially feel like you need these, but as you get better at them, it can be really, really helpful. So let's see. We're gonna hop in and actually make my display settings so that it's a little bit bigger. Let's go to here. So sketch constraints are hopefully, let's see. Okay, question is, we check in, is everybody able to hear things? Let's see. Can you hear me? Can you see the screen? Okay, I see heads not, one head nodding. That's all I've got pulled up. Okay, just checking, making sure that we're good. So, all right, sketch geometry, sketch constraints, those are very helpful. Parameters are another one that are really a good way to understand sort of how you're going to build things. And so parameters are these dimensions that you can set in where you can define how big things are. And this is one that's a little bit trickier to make sense of, but when you figure out how parameters work, you can use this to specify how long something is or how tall something is, and give them variable names. So like in the case of the doghouse, if I head back over to representative doghouse, I'm going to finish this sketch. I can head over to this and modify my parameters. So in this doghouse sketch, one of the things I define is the material thickness as 3/4 of an inch. But if I change that up to 2 inches, it changes the thickness of the doghouse, like the thickness of all of the walls. So if I go back down to 1 inch here, you can see that that gets smaller. Or if I have, instead of a dog that is 15 inches long, maybe it's going to be a very long dog. It's 24 inches long. So I'm able to change the parameters, and then my model will change on the fly with those parameters. This is definitely a little bit trickier. When you're doing this, you have to be careful. Like this extrusion is how I made the length of the extrusion, and you can see it's named relative to that parameter. So dog length is the name of the distance. I did dog length times 1.25, but it's based on that variable. So when I change the variable, the length itself will change. Getting all of your relationships just right for this can be a bit tricky, but once you've got it and you figure out how to do parametric design really nicely, you're going to just start designing everything parametrically, where you have your designs and shapes all set up. Because then you design something and you do your first model and you realize, oh, that size is a little bit off, I want to tweak it. You can just change it in the parameters. And if you designed it well, it can change on the fly. It's another one that is a feature that I look for. It's a cut factor. If there's not parameters like that in a software, I don't want to get cozy in that software for 3D design. And Onshape has them and Fusion 360 has them. They work very differently in the two softwares, but they totally work in those contexts. And then another one that's important as an advanced idea are joints and joinery. So when you get to designing, you're going to have pieces that come together with multiple parts, and they might move relative to one another. And so you can define pretty strictly how those pieces are going to relate. So in the case of this, the like little X-Acto knife that they've got here, the Autodesk example, they defined that slider can only move back and forth within that opening. If they didn't specify with that joint, it would be able to slide along, you could drag it around whichever way you wanted, but you can do constrained joinery so that pieces can only move within constrained amounts. So it's a really helpful way if you're trying to simulate something or see how it works. It's especially if you're building complicated things, this can be really helpful. Another one that's an advanced skill, but is really wonderful is the use of patterns. And so patterns are another one that if you have a lot of repeated things, it's good to know how to make them and how to make them work. This is an example of a sweep, by the way. I've got an ellipse that I just swept along this line. And so you can make really goofy, weird shapes with two sketches. And then this is the pattern where I made just a few little adaptations. This is like a little hole that might be a screw mount or something on this. And then I wanted it to follow along the entire length. So I took this feature, and then you can say I want a pattern along a path, which I think is the most interestingly weird pattern that you can have, where you follow the path line and then you can make a pattern that way. There are very much more useful, I would say, and more common rectangular patterns and circular patterns. Like the rectangular pattern logo is right up here. And those patterns, rectangular and circular patterns, can be used in sketches. They can be used in features and all sorts of places. This pattern along a path that's really neat and being shown here is only usable once you already have 3D geometry. So it's a neat trick. There's all sorts of little details and options when you're using this one. But this is another one to look for in a software if you're trying to choose a software that you like. And here's where it gets weird. We're going to go over some of the alternate methods of other ways that you can make stuff with 3D design software that are really bizarre. And so first up, generative design and topology optimization. These are both relatively new. Generative design is still very new. It's a paid feature, even if you have a really high tier of Fusion 360. But in generative design, the computer does the design work for you. And you get these crazy organic shapes that are being generated by the computer to meet the design rules that you set up for it. And then it can spit out for you 150 designs and you choose your favorite one. That's a paid service, the generative design, but topology optimization is free. And so it's a thing that's been in Fusion 360 for a long time, where you put in like this big chunky part and then it cuts it down into it does a stress simulation and decides what are the pieces that you really need to have of that. And so I've got a video linked right here where somebody does that for a set of shelf brackets, and you get these crazy otherworldly looking shelf brackets that totally look like they come out of an alien spaceship. So that's a ton of fun. But there's a lot of information about these two processes, and I would really encourage you to explore if you're already an advanced user in CAD software. This is a cool one to dive a little deeper into. So totally worth looking at. Another one that's really cool is parametric design. And this is certainly a more advanced concept. It's something that Grasshopper and Rhino are really good at, and a few other design softwares. But nervous system has probably gotten the most famous for it. Parametric design is something where you have a computer programmatically build stuff. And so the lady in the dress there, that's a 3D printed dress. They're all little discrete pieces that print in place in sort of like a box of folded up on itself stuff. And then it snaps free, and they're interlocked in such a way that they flow like a fabric. And nervous systems that's what they got famous for. There's like CNN pieces on them for that printable dress. There's tons of cool stuff, but they also make jewelry and lampshades and puzzles and all sorts of stuff. There's tons of interesting options. Turns out the plastic dress you can get sized perfectly to you, but it's a pretty expensive download because it has to be it's designed by them. But there's, their algorithm is just what they use to build it. There's tons of interesting options for it. This actually has spawned an entire interest in how do you 3D print clothing, or like how do you laser cut and do fabric and fashion in this digital space. Like one of the things they advertise is that their bracelets here are completely unique. You can input something that's like personal settings, or maybe even it would be neat if they started off with a fingerprint and then like go from there. There's tons of interesting ways that you can creatively think about building designs. But down here, the Metropole parasol, I'm not exactly sure if this one was parametrically designed. It's in Seville, Spain, but it definitely looks like a thing that was parametrically designed. There's examples like this where a 3D geometry can be turned into a series of cut files. And so that's exactly what you're asking about, Aaron. Having cut plans for this from your 3D designs can totally be a way to build something that's really neat. We're going to explore a slicer software option that will help you with that a little bit next week, but it's completely a thing that is doable, and it makes for some really fascinating builds. Another thing that's worth knowing about is that there are CAD simulations. Unless you get into topology optimization, I don't think that there's a lot of people that this week will be hopping in with CAD simulations, but it's good to know that this space exists and that they'll color code for stressors or for flow rates or for different pieces to better understand your models. So if you want to really go deeper with that, you totally can. And so there's a ton of options within 3D modeling to explore this better. And simulations are really what separate SolidWorks from some of the other ones. And Fusion 360 is absolutely getting there. They have their own simulation section. But the simulations are an added feature on top of just the being able to draw in 3D. So this is one of the things that differentiates the professional tier software from some of the other tiers. And CAD is for computer aided design, which is a really good question. I thought that I had slid that in there somewhere, but it's computer aided design. And so computer aided design can be lots of things. But this is generally what it means, is the computer design where it's on a computer, it's drawn like this, it's 3D modeled, and then you're doing design work. This is often what someone is thinking about when they're thinking about engineering with a CAD software, is how do we test stress and strain and flow rates and those sorts of things. But then how do you make something, right? What's the next piece? You have all these crazy designs that you've made up. You've designed something. Now, what do you do? 3D printing is the game that we're going to be looking at for this week. 3D design, and then maybe starting with 3D printing. For a lot of people, 3D printing is a nice logical follow-up to having made a 3D design. And I'm going to say that I love 3D printing. It's a ton of fun. It's a great way to make stuff. Some people think it's like a cure-all. The 3D, we're not quite to the Star Trek replicator or where you can 3D print a burger and really eat it in any sort of reasonable way. We're getting there. Maybe one day we'll have those magical things. But for right now, what 3D printing presents is a relatively low barrier to entry. If you can already CAD, or you're getting good at CADing, or you're getting better at CADing, 3D printing is just sort of what you do with those files once you've made them. It's also pretty easy. The 3D printers are set and forget kind of machines. Once you get the file going, it may take several hours. I've had 24-hour prints before. That's not uncommon to have a 4 or 5 hour print, but they are definitely a set and forget kind of machine. So you get it set up and then it prints the thing and you don't have to intervene too much, hopefully, if it's all going to go well. You're totally able to walk away from a 3D printer once it's running, but I would definitely recommend that you don't leave until the first couple layers are down. You just want to see that it's got good bed adhesion, that it's got a good start. And if it's going to fail, it's better to stop it early and then try again rather than figure that out after you've invested a few hours in it. And then filament that you've wasted. But the process of going from an idea to a 3D printed thing is a little bit complicated. There's many steps there. Luckily, they've been solved mostly at MakeHaven, but it's just good to know sort of what those steps are as we're going forward and thinking about what this is. So again, several of you probably already know what these steps are, but it's just good to explore them. So first off, you're going to have a 3D model in your design software. So in Fusion 360, all of your files are saved on the web, and you don't even need to worry about managing the files themselves or their file types. It's great. It's another reason why I like Fusion 360. From there, you'll get an exported STL file, and I can show you how to export an STL file by just hopping over to Fusion 360. You choose any body that you want, you right click on it, and you can choose save as an STL. And then boom, I've just saved it, and we're going to say Doghouse STL, and we'll save it there. So this is now saved as an STL on my desktop, which I'm pretty sure I can hop over, and if I didn't lose it, Windows 10 now has a STL viewer. So you can see in here, if it'll let me view, it's tipped it up a weird way. Oh, Alt and that to pan, zoom, orbit, right click to orbit. So there's the STL file of the Doghouse. There's no features. It's sort of goofy, right? It doesn't look quite right. But what an STL does is it saves all the geometry of a shape. And so it's got all of the geometry information, and it's sort of like a PDF. PDFs, it's like a 3-dimensional PDF, really. PDFs go well between different softwares, and STLs go well between different softwares. They're not going to be editable, just like a PDF isn't really an editable thing once it's a PDF, but it can go easily from Microsoft Word to whatever printer you want, and the printer will understand. In the same exact way, STL files are what you need to go from a 3D model in some weird software towards a 3D printer. And so you export from your software an STL, and that type of file has the geometry information, but it loses all the stuff that's just tied to that one design software. So it makes it essentially a 3-dimensional PDF. From there, you'll import that geometry into a software that's called a slicer. And at MakeHaven, that's Slicer, SLIC3R, or Cura. And Cura is really, Slicer is open source, and Cura is hosted by Ultimaker, which is great. And Cura we'll talk about. They have lithophanes, which is cool. You can turn a photo into a 3D print, but that's its own whole other discussion. But the STLs, once they're in a slicer software like Slicer or Cura, they get turned into G-code, which is sort of what you see up here in this center picture, where there's a series of little streaks, and then these pink ones in the middle, and then there's this line on the outside, the skirt, and all of those are like where the 3D printer's head is going to move around and how much it's going to ooze out plastic. So a G-code is where you have a slicer takes your geometry, what's here on the left, that's just a bunch of triangles, and turns it into a series of paths for the 3D printer to follow. And once it's got that, then the G-code is what the 3D printer actually uses as instructions for how to make it. G-code is common across all of our machines. So the laser cutter and the vinyl cutter and the CNC, they all use G-code, but probably 3D printing is where I learned about G-code the first, right? That it's just a series of instructions for motion from a set of stepper motors. And it turns out the 3D printers are very nice and very vocal about that's what they've got, and that's how they're moving it around. So this is a good opportunity to explore. And as you're trying to take an STL through a slicer to G-code, you're definitely going to notice those file types as that happens. And then the last bit is once the G-code's there, then the 3D printer just follows it, right? It moves around its motors, its print head, and all those things.
For a second?
Yeah.
So I'm familiar with slicers, like when using 3D print software, like the Octo stuff we use there. But what other kind of programs do the slicing portion to get from STL to G-code?
That's a good question. Simplify 3D is one that I was used to, and this is a really nice one. If MakeHaven wanted to buy this software, I would not be upset about it. But this is another one that has a really nice level of detail and support where you put in your STL file and then you've got all kinds of fine-tuned controls. Like here they're showing a multicolor print where you would have green and blue. They've got all sorts of different settings. These are like their iconic little frogs that are a good example for how well they can manage multiple colors of filament at the same time on a printer. This software is just another one, right? They're all different software options for how you would get there. If we pull up Slicer, this is another one. That Slicer is one that wasn't intended to have an interface. It was meant to be sort of a machine run thing. And so it wasn't designed to be as pretty as Simplify 3D was, but it totally does a great job of slicing and getting the job done. It's very full featured despite not quite looking like it. And so it's definitely a good one to have. If you wanted to install this locally, some people really like to walk into MakeHaven with an STL to be ready to print. Other people want to walk in with their own G code to be ready to print. Because I can never remember the size of the printers at MakeHaven. I usually show up with a STL and then slice it there with the printer right next to me. But that might not be true for all of you. You might decide that you want to have a little bit more control or be in charge of that in the right moment. So if you wanted to install Slicer or Cura, you totally can on your local machine. It's worth doing just to see how that goes. If you're going to design and then slice right there, you can bring your G code or just play around with it to get comfortable with it. With either of those slicers to make G code for a printer. One of the things I intend to do this week is to come out with all of the dimensions of our print beds so that you could know this is printer 1, printer 2, printer 3, printer 4, and we'll put that on the Foundations channel so that everybody has that for reference. It might already be on the website somewhere, probably is. But those are all things to take a look at. But then once you have your G code, you just send it to the printer and it follows it. And hopefully, fingers crossed, nothing breaks and it just magically happens. This is true for our FDM printers. We're going to explore a little bit later how this works differently for different types of materials. But the plastic PLA printers are what I would steer you towards as a starter project. They're a little bit, they're pretty universal. They're the thing that, like my sister, who is not particularly tech inclined, just bought a 3D printer for herself. And those sorts of printers are really good for hopping in and being around for all those things. And so being able to jump in and see how this works is probably best with fused deposition modeling or FDM printing. Essentially, it's like the printers that I'm going to recommend you use are the ones that are on that table, not the Formlabs this week. Try and stick to the front ones if you haven't ever printed before. But essentially, it's like oozing out a hot glue gun and then piling up the hot glue on itself as you go, right? You draw a line, you let it cool, you draw another line, you can build a little wall if you are really slow and patient with a hot glue gun. That's essentially what 3D printing is. And we're just going to explore how you can make all sorts of shapes like Bender here. So there's tons of interesting things there. One of them that's important to note about our particular application for 3D printing at MakeHaven with the printers that are there is that Octoprint is the interface that you're going to use. And Octoprint is really clever. It's a super nice way to interface with a 3D printer. And I've interfaced with them in all sorts of different ways. Like Simplify 3D has its kind of own Octoprint-like solution. Then there's just sort of the put a file in and then the printer knows what to do with it kind of solution. But Octoprint is what's at MakeHaven. And so it's a neat way to make it happen. It's a thing that's loaded up on a Raspberry Pi. It's actually a web server run on a Raspberry Pi attached to the printer, and it's got usually embedded in it slicer software. So it's a complicated amalgam of pieces that come together that for you are just going to load up and it'll be Octoprint. So if you're at MakeHaven, if you've done the badging for a 3D printer, you're going to have seen Octoprint, and just know that it's actually a collection of things all put together. The Slicer and Cura are the slicers. The Raspberry Pi is what it's based on and hosted on. And then Flask is the web server that's serving all of this to you. And because it's all completely open source, it's really extensible. There's all sorts of interesting things that you can do with Octopi. Like there's even time lapses and cameras and things that we can get tied into it. But it's a neat thing. The nice thing at MakeHaven though is that you can walk in with an STL and just say, I would like to print this. And you can go from STL all the way to printing inside of Octoprint. So you don't have to come with everything super prepared. You can show up with just some geometry and then make it happen, which is really a great way to do this. A couple gotchas. So if you're trying to 3D print something this week, there are a few things that you want to keep in mind. And the first one is time. Prints can take a long time. And usually the more vertical they are, the longer they take. But beyond time and the fact that it can take a long time for prints to happen, here's two other items. We've got overhangs and supports. And usually people think about overhangs and supports because a 3D printer prints out that row of plastic. And so if you're imagining the hot glue gun being laid down on top of itself, the hot glue being laid down on top of a cooled row of hot glue, that works totally fine. But it's a problem if you want to put it over a gap, right? If you want to bridge something. And so there's three types of overhangs that people usually talk about: the Y, H, and T overhangs. A Y overhang, you've got a central spire and then they sort of fan out from that center, like the top parts of the Y. Those are usually not that big of a problem because they're the rows above, even though they're sort of extended, they're also like 50% over top of something. There's some angle where if you're within that angle, it won't collapse. And so usually 40 or 50 degrees is a good marker for how much you can stretch it. But the H and the T are different types of unsupported overhangs. The H is a bridge, right? It goes out and then it catches on the other side. Those usually go pretty well. So an H overhang, even though the first row may not go well, usually by the second or the third, you're going to be fine. And there's people who even will like design in those so that they, in different reasons in different places. Because these can be helpful if you're trying to minimize how many supports you need to have overall. And then a T is where it's real tricky, right? You're trying to draw out this T and you can see this went poorly. It doesn't, the first few rows aren't going to go well until you get some scraggly ones there that can then act as a foundation for the rest of the letter. So most of the time, this is an unacceptable result for a 3D print. There are some really cool prints that have happened where they deliberately make overhangs occur. Like there's some tree designs where they're trying to make it overhang so that the natural scraggly shapes become the leaves and branches of a tree that look kind of organic. But in order to fight this, supports are really what are at play. And so here, this little, I don't know, maybe it's a Pokemon, because I guess I got a Pokemon theme going. This little guy right here, this little blue fella, has some supports underneath him that look to be a different color. So supports like that would be meant to be broken away, or sometimes if they're white, they're a special material called PVA that will actually dissolve in water. So you print them, it's there to hold up the plastic, so you're not printing into thin air, but it dissolves away in water. And then you get a 3D print that doesn't look like it ever had supports underneath. And I will say the PVA stuff is brilliant. It's great, but it also leaves it kind of slimy. So it's a little, I don't know. I don't particularly love PVA because the texture is weird when you're taking it off, but it totally works. I've had people with good success around me using PVA, but I'm not a giant fan. And then next up on the right, one of the big things that's another gotcha is if your piece doesn't stick to the bed. So I said, don't leave until you've got a couple layers down. And that's really because the first few layers are really important for your print. So one of the things that absolutely I would say is a must is you want to have a skirt. And almost every slicer software will put a skirt, that line around your design, just so you know you're not going to hit anything. That's really helpful. But a brim will sort of extend out the bottom of your part. And that's so that it's got more grip to the base. You definitely want to have a certain amount of touch, contact with the base. And your biggest flat face is something that I would say you want to try and put down on the print bed if you can. There's some reasons to orient in different ways, but usually the largest, flattest face is what you want to sit on the bottom of on the print bed. And so a brim will help expand that base to just give it more grip. It's a good way to go. A raft is another option. If you have a particularly long lasting print, like if it's going to print for 18 hours and it's on a heated bed, the heat from the bed can eventually warp up the bottom. And so you print your entire thing sitting on top of a raft is a good way to go, because a raft then would absorb that extra heat from the base. And if anything's going to warp, it's the raft that you're going to throw away before you're done. So these will probably be checkboxes in your slicer software for skirt, brim, or raft. I would always say yes to a brim, pretty much. And a raft I would do if I know it's going to be a very tall, which pretty much translates into a very long time for a print, just because it keeps from the bottom of the print warping up on you. But these are all things that you play with. There are people who absolutely love 3D printing, and they will have very, very strong opinions about all of these things. And there are many, many, many YouTube channels dedicated just to the mechanics of 3D printing and what's the best way to get things to stick to a bed, and what's the, what settings should you tick, and how do you adjust those features. You can go really deeply down the 3D printing rabbit hole. And I love 3D printing. It's a great way to make stuff. I think that it's something that I put into the tool set overall, and it's good to know about. But I personally, I'm not quite as excited as there are some people in the world. It's really cool. I love 3D printed things, but also it's not like a total panacea quite yet. Not until we can have that real Star Trek replicator. But so what's next? What do you need to do this week to try and explore things? How do you get started? Where's this going? And so I'm going to say you should download and install Fusion 360, or maybe Onshape if that's going to be your flavor. Again, there's not a firm requirement for one or the other, but they're both worth it to try. Maybe even try both of them just for the sake of seeing what they're like, if you like them or not. They have opposite clicks. One's right click for most things, one's left click, I think. And so, it's just a little wonky, whichever one you like, you stick with it. There's an official tutorial series from Autodesk and one from Onshape. So those both exist. They're really helpful. I would really recommend from Autodesk, look at the interface one and the components/bodies one. Those are really helpful for better understanding the dynamic of those two things. So those are really good. Another piece I would recommend is design a representative doghouse, just to get used to the CAD software that you're playing with. Even if you want to build something way cooler later, just do it as a hello world so that you can get oriented. And I have the design. It's what's going to come up on the next slide, so you can see a little bit more detail about it. And then check out some more software. So if you like the first one or you don't like the first one especially, try out more softwares and see if there's one that you really enjoy. Like Ada's on the iPad, she may just stick with that, and there's nothing wrong with it. But there's tons of different options for which design software you might want to use. If you're doing this for a business, they may have firm opinions, but here in MakeHaven, you can totally pick what you want and go after it. I'm fairly fluent in like 4 or 5 of them. And so I can probably help you out if you choose one that aren't on these normal paths, but Fusion 360 is the one that I'm the most native in. And I'm going to recommend that you try. And then next up, I would say create your own first 3D design. So there's tons of different interesting things. I really like this example. Let's see if we can just do this. Here's an example. If we get through the ad, skip the ads, of just a nameplate. So here, this guy designed for himself a nameplate that you can print out. You could put on a desk. If you've got a desk where he just rotated his name on up, that's a cool way to go. All designed in Fusion 360. So there's a link to it in these notes. You could be inspired by Thingiverse, which is a really cool place where there's STLs. If you're having a hard time designing something, you can go on here and just download these designs. These are freely put out there so that you can download and then print them. Oftentimes they're really fun or they're really useful. They can be all sorts of cool things for you to explore. One of the big ones on here was cat armor. I wonder if that's still near the surface. It must be, right? Cat armor has to be. 3D printed cat armor. Look at that. This is exactly what the 3D printing culture is all about, right? This sort of quirky, off the cuff cat armor. I'm sure that there's pug armor somewhere. It's got to be in there. But those sorts of things are fun. Electronics enclosures are good examples of other stuff. An Arduino box would be really good to have. There's all sorts of things that are cool to look at in there, and that would be easy to make. So totally go after it with that. And then I think that this week, if you could try and 3D print something really small, that would be cool. There are a bunch of printers in MakeHaven, and so we can probably all be on there at once. You just need to keep in mind that they can take, pug armor photo shoot would be great. That they can take several hours. So if you want to set up a print and let it run, you may need to show up and start it and then come back later to pick it up. There are definitely prints that can happen in less than 15 minutes, but they've got to be small. Or like if you're printing out something that's the size of a nickel, that's going to be a 15-minute print. Once you start to get bigger, time really balloons with these things for 3D prints. So you got to take that into account a little bit, but it's a lot of fun. So here's a little bit more information about the representative Doghouse. I really like this as a first project, as a hello world for a 3D design software, because it's relatively quick. You can do it with one sketch like you saw I did, but you can do it with more sketches if you want. And it just gives you something to play around with the features of the new design software. It gives you just enough to explore. Do you like it or do you not? I would totally recommend everybody makes a Doghouse. I think I chose mine to be made out of cherry because you can choose your material in Fusion 360. So you can choose whatever material you like, whatever shapes you want, but it just gives you something to explore. Fusion 360 also will spill out nice designs like this. So if you want to have a cut list that's generated just like this, you can totally put out professional looking documentation to play with. So there's totally useful pieces that come from software where you can get all of your shapes and this can come together. You can have this stuff. This is, it depends on what Ruby asked, is this a cut list? And I would say a cut list is probably more like you want to have a set of 2x4s or a set of different pieces. I would love to find the skate park example that my friend Craig made, but it was a series of lengths that you had to cut your 1x1 inch square tube at. And so a cut list, I would say, is more like that, where it's saying you need 15 that are exactly 96 inches long. You need 12 that are the end at a 45-degree angle and are 18 inches long. A cut list would be like that. This is going to be closer to a cut list, and you could use it certainly to identify different parts or components that you'd want to cut. But that is, so far, a cut list is something that's a little bit different. When we get next week, we're going to go into sort of how do you make, maybe I should preview sort of where we're going with that. Next week, we're going to talk about making in 3D. I've made 3 slides of next week's. But as a preview, we're going to go over advanced 3D printing, 3D scanning. And then I was still sort of seeing what else to put in here. But DXFs to go from 3D to 2D, and then some 2.5D stuff is where we're going to go. Cut lists are going to make it on this list. So because of we're going to just add it right now. So there's all sorts of things that we're going to play around with over the next 2 weeks as we think about 3D design and 3D making. And 3D printing is one way, but you can also you can make 3D designs with a laser cutter. So we'll explore all of those pieces as we move forward. But I think that we're at it for time. So I want to stop talking and hear what's been happening with all of you. Oh, my camera did totally die. Look at that. Do a quick cut. Okay, I'm back.
Either that or you just turn the lights out. I mean,
yeah, that was OBS.
Strange things do happen. Yeah.
Mm-hmm. All right, so let's see. Anybody around willing to share? Got things queued up? Aaron, you're unmuted. Would you like to? Have you done anything exciting this week?
So much to my chagrin, work has been insane. I worked over the entire weekend, so I didn't have any time to really get to the fun stuff. But Corey, thank you for some of your help in guiding me towards what it is that I'm trying to do. Basically, what it is I want to use a Node MCU ESP board to be able to control LEDs just as like a notification light. So that way I can programmatically use other systems to use that light as a notification light. So whether it's getting an email from somebody or something happening in another system, like my home assistant thing that I need to pay attention to, I'd like to sort of create a tool that I can focus and not pay attention to things until that LED is a certain color. That I would really like to just be able to have that peace of mind. So I've broken it down into a few discrete steps, and I look forward to getting the time to start working on it.
That's cool. Yeah, it was. We went back and forth a little bit, and it looked like there was a really neat software solution where someone had already part of it was done. Like you'd need to customize it.
Yeah.
But it was a surprising amount.
I think I'll prop, it would be my guess based on a couple of the guides that we were looking at, that I could probably have the basis of something in just a couple of hours, but then I'd probably spend just as much time tweaking it to sort of get it somewhere where I might be able to make it easier for myself to use. So I need to set my aim a little bit lower, I think. I'm going to try to do the simplest thing first. Because even though I have like some knowledge of some of the parts of my puzzle, like make it easy where I can, I guess. So
yeah. And for first projects, go easy is one of the things that is hard to do, but is really, really helpful when you're doing early projects. So it's totally just get the light to blink is the way to go. Hello world space is a good place to live. Kate, you're unmuted. Do you want to share?
I'm unmuted. Let's do this. All right, I'm gonna try to share all the stuff. One thing that I wanted to show you guys, this is what I mentioned when you guys saw the dress. This was a UNH student, and she 3D printed kind of like a chainmail, but basically this she used it. I don't know how well you can see it right in here, but that's the fabric, and so she used it like that. So if anyone was interested in that, let's see if I can get a website. Aha, here we go. So here we have this week. I know. This is how I get through.
I haven't laughed in a while, so it's pretty easy to get me right now.
So I made the shield, a little light the blinks. So I finished that, which was exciting. Corey got me through it. It's good. Highly recommend using the little microscope to see it up close. I've done a few soldering projects, but I understand it better seeing it up close. And then this is my home soldering station, which is not as fancy. I guess it's a little fancy, look at that. But so this is my big project that I did with Adafruit pieces. And so here, basically, it's going to recognize the color that you put over the color sensor, maybe. So I'm just putting some paper over it, and it's like, oh yeah, that's green. And so it lights up green. Yeah, so that's basically getting more paper. Look, it's blue. So so that was me testing the circuitry and everything. This is me critiquing what Adafruit needs to do better. They did great, but there's definitely some things for the newbie that I was like, what'd you do here? Why'd you skip that? This is me burning myself, the soldering iron. And so this is what it does in the end, which I can try to show you in person. I don't know. It's really hard to photograph this, but basically you put it on top of a camera, and so you can add a lighting effect these are my bathroom tiles, and I turned the wheel and took it in different pictures. So that's kind of how that works.
That's awesome. I want to make one.
Yeah, that's amazing.
Yeah.
Okay, so I don't know if you guys can see this crazy.
Wow, Kate.
Doesn't it look crazy? Like, that's the best part, is that it like really looks nuts. And I think I might have just taken a picture of all of you. And so you can see when there's a wheel up here, and it mirrors on both sides, and so it's reading the colors. And as I turn the wheel, that one's bright. Yeah.
Did you design? I'm sorry, you might have said this, but did you design that, or?
Oh, hell no. No, that was a fully. I can put in the chat that it's like Adafruit. I'll put in also my link with the few things that like they didn't mention about how to do, in case anyone wants to know how to do it, or whatever. But
I'd love to.
It was an Adafruit. Like, they definitely walked me through all of it. A couple of the components were out of stock, but Corey helped me track those down, and it's
well done.
a ridiculous silly thing, but it's exciting to have it done, and it's very bright. I actually changed the code to bring the brightness down, and it's still very bright. Like, I took pictures of my daughter, and she was like gonna close her eyes, and when I was about to take it, she would open them. So it's that bright.
It's so cool. I love a nice canned project like that, because even though it's not as easy as like, here's instructions, follow them, right? There, like you said, there were things that they did that weren't as clear as they could have been. There's all sorts of details that you need to fill out when you're doing a project like that. They're definitely harder than you'd guess, but you get those crazy rewards.
And you can maybe photo print a diffuser to bring down the brightness, or to control it, or to throw the light. I mean, there's so many cool things you can do with that now.
Yeah, there's tons of options. I love the color sensor. It works in a way that I wouldn't have expected. I've used chips before that can like directly tell color, but it would use just a light sensor, and then it would turn on a red LED. You saw the red, green, and blue blinking on the top. That's because it's independently testing each color for brightness as it cycles through them. So like it can tell that something's yellow because or it can tell it's green because it only pings reflected light when it's green, and it can tell it's yellow because it pings back, oh, I see reflected light when it's green and when it's red. So it does interesting things to get a sense of what color the light is that's coming back at it. It's so cool. Like that, it's just a neat project. Yeah. Ping pong balls in front of it for a cheap diffuser. That totally would work. Tissue paper. You could 3D print a ring, right? You could give it a little 3D printed electronics housing if you really wanted to go nuts with it. That's awesome. All right, let's see. Next up, Jamie, you're unmuted. Would you like to tell us about your week?
Sure. And I'm curious if you could help me, Corey, because I just finished it up. I don't even have the finished product pictures yet, but I did all the electrical in my van this week. That was kind of like the big one for me. I did explore more in like Arduino, and I worked on the OOP, and then went down a rabbit hole of like logic gates. Not sure if you can see, but I just started studying logic gates to really kind of get like the not logic, which was confusing me last week. And then just being actually able to see these circuits and just kind of go through them, like there's a few of them. There's the invert not, there's the and, the nan, the or, the nor, exclusive or, just being able to do that. Now I feel like I can now build different kinds of circuits, and I'll start to understand just how chips are made, basically, because all this is built off of these logic gates. So it was kind of exciting just to do that when I was resting my back from doing the van electrical.
Yeah.
And then the one thing I didn't get to, my one big goal that I didn't get to, but will, because I also did, the shift registers and the interrupts, is the encoder with interrupts. I still want to do that project because the encoder on the circuit board I built didn't work. I just didn't set one up, but I have another one I will set up and can. I just didn't do this week.
Jamie, I meant to say that, and I'm so sorry that I forgot this, but one of my best friends from back home is like a 12-volt Yoda, and he does LEDs and electrical work on cars and boats specifically. So I don't know how helpful that might be now. Sorry, it's up my mind, but if it's
No,
helpful,
it's okay.
please let me know. So
thank you, appreciate it.
Cool. So yeah, that's exciting. All right, let's see who else would like to share. Ruby.
Hi, yeah, I'll go next. I will share my screen. Okay, I think I'm sharing screen now. So this week I got an email and I have been in talks with a clinic to maybe install the concept of the cloud lamp in their clinic. And I found out that I have to present to them this week. And so I've just been working on a more fleshed out prototype. So that is what I was working on this week with a lot of help from Corey. So this is, let me show you this first. For that. So in the span of like 5 seconds, where me and Corey were talking about the possibility of maybe using something other than those little cheap twinkle lights, someone came up to us and was like, hey, I have exactly what it is that you're randomly talking about. Do you want it? And I was like, yeah. So it turned out to be NeoPixels. So first I made a base out of chicken wire. I really honestly just, like, here, if you look at it, let me just open this more. Um, this is the back of the cloud. And I didn't close it up just so we could have like an open piece and we could look at whatever it is we were doing. Chicken wire and then polyester fluff kind of just poked through in the chicken wire holes, and it holds really well actually. We did use like some thread to hold the NeoPixels in. And then we used an Arduino and a perf board to be able to connect it to like a computer and to be able to control it. And in the matter of like, what was it, Corey? 2 hours? We went from having an idea to having a real like second good prototype. It was a roller coaster. Let me just put it that way. It was awesome. So this is another video.
Thing two is
so here's just one of the tests in the NeoPixel library that Adafruit has. There is a few different like test options examples that you can choose just to demonstrate that your NeoPixels work, just to test it out. So I'm thinking of proposing something like this, where the cloud like thunders, but also like slowly fades in and out. Here's a close-up of the cloud. I'm really excited because I was not expecting any of this to happen so quickly, but I was expecting to run into a lot of more problems. And I'm really excited that I understand more than I thought I would. So the end goal with this is to have it be able to be plugged into a wall versus a battery. I think that would be more stable, and I think it would honestly just last a lot longer, because I wouldn't want them to have to consistently keep up with it and remember, oh, okay, it's time to change the batteries, it needs maintenance or whatever, something's wrong. But so yeah, I've just been working on that, and I've been working on my presentation, and it's honestly just like describing how it works, and it doesn't feel any different from like putting it on my website as the how-to, which is really comforting in a way. But that's what I've been working on. It's been good.
yeah.
Can I ask a question about it?
Yeah.
So how I have those same kind of LEDs in my van. They're really efficient. There's four little like places to hook them into each other, and I noticed that that's how you hook them up to the Arduino. How did you do that? Did you solder it? Like, what was your method?
Yeah. So let me share again. See, I think you can see it. So Corey gifted me a little perf board, which we placed on top of the Arduino, and then where'd it go? Where'd you go, sir?
Yeah, it was just I'd had it from a project and we just like snipped it off. Yeah.
So
That's so cool.
and then like we sort of opened, like sliced it, because there's like a, what is that, plastic layer on top so the light would diffuse.
Yeah.
Soldered that with a resistor, and then soldered that to the perf board little wire thing. I got really lucky because Corey already had something that he didn't need anymore. Yes.
And what are those other yellow wires going to? Just other
This
LED strips on the perf board.
Oh, they're just leftovers from the old project.
Oh, got it.
Yeah.
That's so beautiful, Ruby. Well done.
Thank you. I'm excited. I hope they like it. And even if they don't, I mean, my hallway is super dark, and like there's like a motion light thing that doesn't really work. I'd rather just have like cloud lights. Way cooler.
Mm-hmm.
Yeah.
But that's what I've had to.
As like a really, really nerdy light person, that is amazing.
Thanks, dude.
Yeah, I look forward to seeing. I want to see a picture of like 5 of them down the hallway. I think that'd be great.
Covering a ceiling.
Yeah.
Can you imagine? Oh my God.
All
You could make a
right.
bunch of them and then like rent them at parties. You know what I mean? You could like there's this wonderful woman I know named Shayna who hosts these like massive Halloween parties. I'm sure some of you have maybe met her. I don't know if her name is ringing a bell, but pre-COVID she'd be famous for throwing these massive Halloween bashes with crazy decorations and everything off the chain. Very expensive tickets, but totally worth it. Yeah, I don't know, just something that came to mind. That would be cool.
That's an extravagant business idea. I think I would have pursued that 2 years ago.
Okay. Yeah.
With my crazy business partner. Not
Hey.
gonna lie. That's not me anymore, but oh my God.
Respect. Yeah.
Yeah, that's so fun. All right, let's see. We've got there's Anna and Lila and Ada and Wagata.
I can go.
Whoever wants to go.
If you don't want to go, Wagata can go.
Oh, you can go. Yeah.
I'm going. I just. Oh, wait, hold on. I worked on that project, and Corey helped me, and I couldn't get it working. I could only really get the
Do you mind if I share? Oh, you're sharing.
Is
Okay.
it working now? Or can you see my screen?
Yeah, we can see.
So this is, I was able to just do this video real quick, like while class was happening, because I wasn't able to connect it. Anyway, it works. It works now. They're kind of eyes, but every time I move it, it kind of loses its touch. But yeah, everyone could see what I did there. And I wanted to make a housing for it that may or may not look like a pug. So yeah, that's where I'm going with it.
It was a good example. I feel like this was a great example of, you found instructions where the instructions were 90% correct, but that last little bit was a really frustrating. Oh, that's really great. Yeah.
So that was one of the what's it called, like a sample on one of the, like, that came with the LED, and that would work. But then, yeah, Corey, finish what you were saying with.
Oh yeah, it was just a great example of, it was 99% there, but there was a line of code that they, maybe at the time when they wrote their example, it was fine, but like it needed to be one line changed and then the whole thing worked. But it was frustrating. We spent a whole afternoon trying to figure it out.
Yeah, and I tried to load one of those, I forgot what they're called, the tiny Uno.
Oh, the nanos, right?
They're also called nanos? Are they allowed to be called nanos?
The like off-brand nano, yeah.
Yeah. And it wouldn't, I don't know, I couldn't get it to load. So right now I'm still working with the Uno. So yeah, that's all I worked on.
But it's neat. The can you pull up the link for the original project? Because it's really cool. You dropped it in the chat.
How do I do this?
Because one of the things that's really neat, and I would like to make sure everybody gets a chance to see, is that those ultrasonic sensors are looking for where your hand is, and then it looks in the direction of your hand, which is really cool.
Okay, here we go. Did that work?
Yeah, that totally works.
So yeah.
And it's just, this is a nice example of an Arduino project. It's got all the stuff there, and then down at the bottom, it's even got the code that's almost completely correct.
Yeah.
But it was, you had said that, what was it about forums and the people, that there was some back and forth, right? In the
There was
comments?
some back and forth, and some people did the project, but I almost believe it was almost like somebody had done a similar project and they posted it just to say they did. But like it was hard to find any other code for something like this, where it was eyes that would react to where you're located.
Yep.
So yeah, there was some back and forth. I saw it was, you really saved the day with getting that code correct. So
well, and it's yeah, it's just you get more comfortable with it with more time. All it was the library needed one more parameter. There's overloaded constructors, or where you can start, like when you do serial begin and you input the parameter for 9600, it just needed another parameter in this particular library. It was a constructor that had an optional one, and you needed it. So
all right.
Adafruit has a kit that I almost bought before I realized it was way too ambitious for me. But they actually had a Halloween, special Halloween kit for eyes, but they're not LED eyes. They're like actually a physical robot eye. And I wonder if they have similar code, because like they also do like this thing where they move around. And I wonder if maybe in that project, it's not like the same output, but maybe like what the code is telling it to do.
So I saw there were project with eyes, because when you look up eyes, a lot of Arduino eyes were for those automatic robotic ones, but this is like very specific with getting it to react to the, I forgot what they're called. Corey, what are these things called?
The ultrasonic ping sensors.
Yes.
Oh, okay.
That's what it was.
Okay. Because I have like
there were some really cool eyeballs projects with Arduino.
Yeah, I think Adafruit even sells one that's like a little OLED screen. That's like and then they've got a lens that they make a Cyclops tutorial, and it's really cool.
That's definitely the one that I came across.
Yeah, there's tons of interesting options.
Yeah. All right, Bogata.
All right, I'll get started. So this is what I made, just a 4x4 by 4 LED cube. Although it's not illuminating, I got what I think is the hardest part set up. So I got all the negative connections here by copper wires. And then I have the positive leads all soldered on the end. All in all, it was about 4 yards of copper in this box right here. So as I was doing the layup, I had this little block here that I put the LEDs in. And so each, well, it's not fitting right here. So I would stack the LEDs in here, bend the leads, cut the leads, and then start soldering all these together. So altogether, it's I mean, if you could see it closer, there's not much solder on a lot of these ends, but it's pretty rigid. It's pretty sturdy. And hold on, let me cancel that. And I tried to get a video on the laptop, but I'll just play it out of my phone. I couldn't quite get it loaded. So this is some Charlie plexing I'm doing to check that I have a connection through all the top layer LEDs, and then I follow through on each of the layers below. So whether you can see it or not, there was one LED that didn't light up, so I'm gonna have to replace that. But overall, the rest of them work fine. So my next step is to create an acrylic box and to get the holes that I could hook up to the bottom of here and get soldered to my little assembly here. So I have a Bluetooth Arduino Nano with the pins hooked up to these bipolar junction transistors. So each of these, I got 4 of them here. So each of these covers a layer, like just a flat plane. And these other pins handle the individual LED lighting. So I think I'll have it done by the end of this week. And when I get it up, I'll post it on the Slack. So
Yeah,
that's what I got.
that was really cool to see the testing. We had like, I felt lucky to be there. Can you describe how you did the testing? Like what you were doing?
Yeah, so I hooked up the ground to the top plane. I had the positive lead. Well, Corey helped set this up. A 330 ohm resistor, and I just connected it to the anode. What would connect to the anode, and the anode is each of these vertical copper wires here. To see that, based on the ground hooked up to the top layer, I should see, if I hook up on one of these vertical copper wires, this LED would light up. And then I go this copper wire, this LED would light up, and then pretty much down the line for that layer.
Yeah, it ended up being really neat to see it test, because you could just like tap, 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 and like in a few taps, you had a whole layer tested.
Yeah, it was a pretty effective method. I actually was going to go without testing until Corey suggested.
It's always good.
So it's
Always
nice
good
it didn't, you know, it's nice that it all worked out. So I'm pretty happy with it.
Yeah, it's real exciting. That's cool. Let's see. We've got Anna or Ada. Either of you want to tell us a little bit about your week, or if you want to pass, you totally can.
I just got my second negative COVID test. So I can go back into the space and actually do things now.
Yeah.
So I have a busy week ahead of me of catching up. So, but hopefully I'll have actual things to show next time.
It's exciting.
Yeah, I'm also sort of like looking at a catch-up week, and then next week, which is good for me, because it's nice that it intersects with the 3D modeling stuff, since that's what I've spent that's what I've spent a large chunk of the last week doing.
There you go. So you're gonna
That's
have a
what I
bomb.
spend a large chunk of most weeks doing, to be honest.
Yeah, that's cool. Do you have I would love to see some of your like coolest designs that you've modeled. And I'm sure that they're probably business things and you don't really want to super share them.
Yeah,
but,
I mean, I'm fine to share them, but not while recording.
Yeah, no, that's totally fair. 100%. It's a thing that has to be actively managed.
Yeah, anytime that you want to share something that you guys don't want recorded for whatever, just let me know and I can always pause the recording.
So cool. Yeah, so it seems like everybody has had an exciting week. I'm looking forward to see what happens. I think that there's many of you that are very artistically bent, far more than I am, and I'm excited to see like what spills out of 3D modeling with an artistic brain. It'll just be cool to see that get explored. There's tons of cool options. One of the things that we were chatting about right before everybody got on the call, let's see if I can find, here's one that's really cool. I need to share my screen to show this off. Yeah, is lithophanes. So especially with Cura, the slicer, here's a picture on a computer, and then here's a 3D print that maps the darkness to like how thick it prints the filament. So in lighter color areas, it's really like maybe one layer thick. And then in thicker areas, like in the hair or the eyes, it would be like a little mountain of filament. So light coming through the back, you get this neat effect that it can be recreated with a 3D printer. These can be really cool to throw onto a lampshade. There's even some software somewhere where, and I think Cura or maybe customizable lithophanes, there's different, it might be one of these will make lampshades where it's like a full panorama picture wrapped around a cylinder, and you can specify what size, where does it go, how does that all work, and it makes really interesting things so that you can just get these printed and spit out. And so it looks like Cura will totally do it. And Cura also gives you print estimate times. I actually would probably also recommend, if you wanted to install more software this week, if you're just feeling like installing all the things, installing Cura wouldn't be a bad way to go. So, oh yeah, and Kate put it in the chat. It's a really cool way to make things. It's totally fascinating. Another thing that would be cool to explore is what if you made the negative of the image, and then it's like a lithophane mold, and then you like cast I don't know, like paper mesh in there. So the material, so it's the negative when it's a 3D print, and then you fill it in with some material like a paper that would be sort of translucent also, and then you could lift the paper out and have the positive again. Like there's some interesting capacities around this lithophane information, lithophane information, where you can really go for it and see how weird this is. Here's, or mute the audio, but you can, like, it's wild, right? It just looks like a photo, and you get different resolutions based on how big it is. And it can really look neat. It looks bizarre from the front because it's the exact opposite. But if it's lit up from the back, they can look really awesome. And then you can get, here's an, I don't know what this one's gonna look like actually. Oh, that's really fun. That's a neat little octopus. I like that a lot. So there's all sorts, it's like the Lolsbot logo. There's tons of cool options for these, and they can look pretty like abstract when they're not lit up from the back. So, and here's this koala, which looks really looks like something happened to that one, but it looks nice overall. Here's a more abstract one. I don't know. Some of them look like they're good. Some of them look like they're a little bit trickier. And it looks like Kate dropped in the chat. Yep, Ultimaker Cura. This is a free download for sure. You can choose your platform. I'm just going to download this now. Thank you. And so those are all interesting pieces that you can take into account. Cura is a slicer, so it's a good example of how you can take a 3D model to an STL, and then you can slice it in Cura, but you can also start from different points. Being a slicer, it's setting up what the G code for how the 3D printer will actually do its stuff. So there's tons of cool options. What's up, Kate?
So if I use Cura to do my slicing, and then is it gonna then give me G code?
Yes, it would give you G code, and you'd bring G code to MakeHaven to put onto Octopi. Also, if you wanted to play around with Octopi because it feels like something that's a little esoteric, it's something that is usually, Octopi is specifically for an for a Raspberry Pi, but Octoprint you can install on whatever operating system you want. And so I've actually installed it on a Windows machine before, just so that I had the ability to play around with it. Oh, it was right as the pandemic hit in March. I took home a 3D printer from the school and was printing face shields, but I didn't have a laptop with the Simplify 3D license, so I had to figure out how to get Octoprint to work. But you can totally download this. That's the Octopi one, but then you can also get Octoprint on Windows. And so you can do this on Linux, Windows, or Mac and have it installed locally. It wouldn't control a printer, but you could play around with it and sort of get used to what the software is if you wanted to. And so it's got a whole set of instructions for if you want to follow these, which is worth doing. A neat thing that could be worth trying to set up if you're already a pro at all these things is getting a webcam server set up for Octoprint, so that at MakeHaven, you could pull up a camera and see how your print is going. Getting that to be remotely accessible is its own whole other thing, but being able to watch or record or take pictures at a certain point, there's some really cool 3D print time lapse things. Again, if you're already good at this and you want to level up your game, these are options. Let's find a good example video of it doing it.
Yeah, if anyone wanted to figure out how to get the camera portion of Octopi working, you would make a lot of friends at MakeHaven.
This is an example of the Octopi. If you want to do an Octopi time lapse, here it moves the print head out of the way and then takes a picture. It has to change the G code to do this because you can see the extruders over here on the side, but the G code moves the print head over, and then with the G code, it says take a picture. So it always takes a picture with the print head in the same location. So you don't have like a time lapse where this thing's zipping all over the place. It just moves out of the way and it's always in the same spot. So your time lapse has the thing moving up along, and here he's editing. Is that many photos? Yeah, but it looks like this. And if you can figure out the camera, I'm sure lots of people will love you at MakeHaven. For sure. It'd be great to be able to pull up on a website. Oh, is the printer free? And then just check, and then you can decide if you're going to go into MakeHaven or not.
I have a question about that.
Yeah.
So is the camera system specifically inherent to a web server being hosted through the Octopi? Does it have to be sort of funneled through that?
No, it doesn't. But Octopi has some nice plugins for it. It's got that time lapse thing would be baked into Octopi. But
Did
I think
it ever work at any point?
Huh?
Do we know if it worked at any point, or was it just never set up?
Oh, I think it was never set up. And then there's the other dynamic for the server of, do you want to port forward into the MakeHaven thing? And so if you could find a way to get a internet webcam and just point it at those printers, people would be happy. Even if it wasn't an Octopi cam, but an Octopi cam would be really nice. So if you're musing on what to do.
I'm thinking about this.
Yeah, it'll be good. Well, I'm sure that maybe even if there was like a Ring doorbell cam pointed at them or something.
You could get a Wise pan tilt zoom cam for like $25 and just hang it from the ceiling, and then just, you could log in and move the camera head around. Oh, lots of gesturing going on over here.
I think just even if you just point it down.
Yeah,
over
just
the
point
floor.
it down. Yeah.
Yeah, I think that would do a lot of it. Cool. All right. But yeah, I think that's probably those are the things that I initially wanted to make sure that we talked about. And it's exactly 9 o'clock, everybody. Maybe we should officially stop the recording at least. And then if we have any other questions, thoughts, or concerns, we can totally talk about them.